Hi, welcome to my video on find all trig ratios of theta. If a point lies on the terminal arm of theta, and again theta is an angle of rotation. Find all trig ratios of each rotation. Here's an example. We have a point 9, negative 12 lies on the terminal arm of theta, so we got to find all the trig ratios. So let's draw a diagram. This is x, this is y, and this, again, x is positive on this side, y is positive going up, x is negative on this side, and y is negative going down. Oh, put a negative there. So x is 9. If we want to stretch this out a little bit more, look like it's, so x is 9, let's move 9 units over, let's pretend that's 9 there. And y is negative 12, so that's down here. Pretend it's right here. And so the point 9 on the x, negative 12 on the y, hits this corner point right here. So this is the point 9, negative 12. We draw a terminal arm going to this point. And there's a circle. There's the radius of the circle right here. So we draw a circle that goes around. There it is. And theta lies on this, passes through the, lies on the terminal arm of this rotation. So if I extend that out there, the rotation is right around, keeps going all the way around. I'm doing the, on the arc, here it goes. There's the rotation. This is the rotation theta. So this value of theta is somewhere between, that's a 90, 180, 270. So this value of theta is somewhere between 270 and 360. So we drop a right triangle to the x-axis. So x is 9, so that's the x. Y is negative 12, so this is the y, negative 12. The reference angle is right here in this corner between the terminal arm and the x-axis. And this angle is going to be between 0 and 90. Not worried about finding that angle yet. And we have to find all trig ratios. So sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent, which is the sine is, in relation to the reference angle, the sine is the y over the r, the cos is the x over the r, and the tan is the y over x. And that means a sine, so cosecant of theta is r over y, secant, c is an s, so that's r over x. Reciprocal of tan is cot, which is the x over the y. So here we go. Sine of theta, cos of theta, and the tan of theta. Let's find those first. So the sine is the y over the r, so that's negative 12. Oh, we got to go and find the radius. Well, forgot to find the radius. So let's find the radius. X squared plus y squared equals r squared. And the x is 9. The y is negative 12. R squared, 81. Negative 12 squared is 144. That adds up to 225 r squared. So the square root of r squared is plus minus the square root of 25. Square root of r squared is r. Square root of 25 is, square root of 225 is 15. And so the radius is never negative on a circle, so 15 is the radius. So let's put 15 in. And now we can work out sine is the y, which is negative 12 over 15. And we reduce that. We get 3 into 12 goes 4. 3 into 15 goes 5. So it's negative 4 over 5. Cos is the x, which is the 9 over the hypotenuse. And that leads us 3 into 9 goes 3, 3 into 15 goes 5. And tan is the y, which is negative 12, over the x, which is 9. And we reduce. 3 into 12 goes 4, 3 into 9 goes 3 times, negative. And without automatically, when I find the primary ones, then this is CSC. Automatically, I can just do the reciprocal of these, which is a negative 5 over 4. Reciprocal of cos is secant. I can do the reciprocal of 3 over 5 is 5 over 3. You can work them out this way, but because you have sine, you get his reciprocal. Because you have cos, you can get his reciprocal. Because you have tan, you can do the reciprocal. Reciprocal is 3 over 4, but I do not put the negative in the bottom, so I put the negative in the top. So you can work them out this way and this, but once you get these three, then you got the reciprocals. So this is the radius over the y. This is the radius over the x, and this is the x over the y. Okay, let's continue. Practice. Find all primary ratios of alpha if the terminal arm of alpha passes through the point negative root 5 and 2. So let's draw that. Here we go. So again, this is the x, which is positive, and this is y, which is positive, and this is x, which is negative, and this is the y, which is negative. And the point negative root 5, 2. So x is negative root 5, so we'll just estimate, don't have to be exact. There's the negative root 5. And 2, let's say 2 is right here. And so the point is, this is the point that got negative root 5 and 2. Terminal arm goes through that point from the origin, 0, 0. And we have a circle that passes around like that. So alpha is the rotation from the initial arm, moving all the way around. So there it is, goes around there, and there's the rotation on the circle, stopping here, and this is alpha rotation. But we drop a perpendicular to the x-axis, and the x is negative 5, negative root 5, the y is 2, and this is the hypotenuse, which is the radius of the circle from here to here. That's the hypotenuse of the right triangle, which is the radius of the circle. And we have to work out, last time I didn't, now we got to work out that r squared equals x squared plus y squared. Remember, you can write it down, x squared plus y squared equals r squared. It's your choice. But it's the Pythagorean. It's x, y, all squares. So r squared is x is negative root 5. Y is 2 being squared. So r squared is negative times negative positive. Root 5 times root 5 is 5. 2 times 2 is 4. So r squared equals 9. The square root of r squared is plus or minus the root of 9. Square root of r squared is r, plus minus 3. So the radius is never negative, and in relation to the length of the segment here is always positive. So that's the distance, like the absolute value. It's always positive. So the radius, so we want to do sine of alpha, cos of alpha, and the tan of alpha. And sine is opposite over hypotenuse, which is the y over the r. So, and the reference angle is right. So the reference angle is this angle here that determines it, even though I have alpha rotating to here. This is the angle, the reference angle. And I just put an REF. Reference angle is what determines this ratio. So it's the y, which is 2 over the radius, which is 3. The cos of the reference angle, again, is the x over the r, because cos is the adjacent over the hypotenuse. So it's a negative root 5 over 3. And the tan is the y over the x. Tan is the opposite over the adjacent. So the y over x is 2 over negative root 5, which is negative 2 over root 5, multiplied by root 5 over root 5, and that gives us a negative 2 root 5 over 5. And we got sine done, so the reciprocal of sine is cosecant alpha, and the reciprocal of 2/3 is 3 over 2. Remember, that's the y over the r, this is the r over the y. And reciprocal of cos is secant alpha, and the reciprocal here is 3 over negative root 5, but we never put the negative in the bottom, so we go 3 over root 5. And we also rationalize the denominator by multiplying both by root 5. So that gives us a negative 3 root 5 on the top, and the denominator, root 5 times root 5, becomes the root of 25, which is 5. And the reciprocal of tan is cot, and the reciprocal of, now you can flip this one around, or you can flip this one around. It's your choice. If you flip this one around, you put your radical down the bottom. So because this is worked out here, so why not flip this one around? So this is a negative root 5 over 2. If you flip this one around, you're going to put your radical back down the bottom. But just to explain that, if you did this one, if you did 5 over negative 2 root 5, that becomes negative 5 over 2 root 5 times root 5 over root 5. So that gives you negative 5 root 5. Root 5 times root 5 is 5. 2 times 5 is 10. And notice the root 5. 5 and the 5 goes once, 5 and the 10 goes 2, so that's a negative root 5 over 2. So by taking this and doing the reciprocal, you've got to do all this work to get a negative root 5 over 2. So it's easier to take the initial one right here. You've already simplified this to here. So when you do the reciprocal, if you know what tan is, then do the reciprocal of tan from the initial, and it works out easier. And that's finding all the ratios. And hopefully, again, you have it memorized. And just to repeat, sine of the angle, but no matter what, alpha, sine is the y over the r, cos of alpha is the x over the r, and tan of alpha is the y over the x. And reciprocal of sine is cosecant, so that's r over y, and secant of alpha, as you see, is the r over the x, and the cot of the angle of rotation is the x over the y. Again, I have this memorized because sine is opposite over hypotenuse, and in a triangle, the opposite side is always the y, and the cos is always the adjacent, which is the x. and tan is always opposite over adjacent, so it's why I have it memorized. And then I do the reciprocals. And that brings us to the end of this video. If you like the video, click the like button, the subscribe button, notification bell. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.